Welcome everyone. Today you guys are going to take a role play on a fascinating world of AI. And in this role play, you guys going to explain about what is the working principle of a neural network. In neural network, you're going to explain what are the components in it. So start the session with a small intro and what is the role you're going to play.
Hello, I am Arjun. I am playing the role character.
I'm Janisha. I'm going to play a role on input layer.
I'm Anupriya. I'm going to play a role on synapse and weights.
I'm Kritika. I'm going to play a role on tester output layer.
I'm Jayasuriya. I'm going to play a role on hidden layer.
First of all, imagine we show a picture to a human and ask, is this a cat? Within second, we recognize the using experience. We see ears, visual shape, visual texture. But a computer does not see like humans. For a computer, an image is not a cat. It is only a collection of numbers. So the real problem is, how can a machine convert raw numbers into a meaningful decision? To solve this, scientists designed the perceptrons, the simple decision making unity artificial intelligence. It is acts like a artificial neuron, inspired by how our brain cells make decisions.
Why can't AI just see like humans?
I'm input layer and I'm responsible for clearly defining the numerical problems. When an image is given, I will break into features like how bright the image is and how the feature is, where the edges are detected, what shapes it is present, pixel intensity, texture information. Each of these characteristics becomes a number. For example, if the image has a stronger edge patterns, it will be in a higher value. If it is in a poor texture, it will be in the under value. I don't know whether it is a cat. I do not think. I only organize and pass information. I'm like a data collection officer in a company.
So you only collect information and pass it forward?
Exactly, if I send the poor quality or incomplete data, even the smartest person can make corrections. So here, information is very important.
Synapses. Now the data reaches me, but here's something important. Not all features are equally important. For example, ear shape may be very important for detecting a cat. Background brightness may not be very important. So I assign importance level to each input. This importance is called weight. If a feature is strongly related to the final answer, it gets more important. If it is less useful, it gets less importance. This helps the perceptron focus on relevant features. I act like a filter or a priority manager.
So what if we give a wrong information is given us?
Then the perceptron may focus on the wrong features. For example, if it gives more importance to the background, instead of shape, it might misclassify the images. But that is not failure. That is how learning begins. When mistakes happen, wait or adjust. Over time, important features are strong and influenced, and unimportant ones begins weaker. This is the ideate stage.
Hidden layer, perceptron. I am the core decision making input. After receiving the weighted input, here I perform a structured labeling. Here, what happens inside me? I consider all weighted inputs together and I evaluate the overall signal strength. And I compare it was decision making in the boundary. If the combined signal is strong, it will say yes. Always it is weak, then its result will be a no. Then think as it is like. If the receiving is strong, then the answer will be yes. If the receiving is not well, then the answer will be a no.
Why does perceptron only gives a certain answer?
Because a perceptron is a binary classification. It can separate data into two categories only. Most complex decision require like multiple perceptrons and multiple layers. But intelligence is step by step. Even complex neural network are built from simple perceptron like me. This is a prototype stage. We are building a model that attempts to solve your problem.
Output layer, I receive the final decision from the perceptron. I do not modify it. I do not modify and analyze it. I simply communicate the result clearly.
If the signal says 1 cat, 0 not a cat, in a real world industries, in medical AI, tumor or no tumor, in email system, spam or not spam, in manufacturing, defect or not defect. My role is clarified. This respects the test stage. We check the system.
So you don't learn anything.
Correct, ma'am. I only display results. Learning happens in the internal life.
Okay, now discuss about what are the activation function and what is the purpose of activation function.
Activation function is a rule applied to the output of neuron that decides should the neuron activate or not. How strong should the output be? After a neuron receives the inputs and process them, the activation function converts the result into a meaningful output signals. In simple words, activation function transforms a raw signal into decision.
Okay. What are the types in activation function? The first main type.
Sigmoid activation function. It is a S-shaped curve. It lies between 0 to 1, and its formula is 1 by 1 plus e to the power of minus x.
Okay. Next one.
Second type is a ReLU method, rectified linear unit. Because of its simplicity and performance, mostly the deep learning uses the ReLU method. The formula of the ReLU method is f of x equal to max of 0 comma x. It value ranges from 0 to infinity, and if the input is greater than 0, the output will be 1. If it is less than 0, and the output will be 0.
Okay, good.
And third one is leaky method, ma'am. Whereas the ReLU method regrets the negative value, but the leaky method accepts the negative values, and it the values ranges between minus infinity to plus infinity.
Good.
So next method is tanh method. Tanh method is used in tangent hyperbolic areas. It ranges points from minus 1 to 1, and its formula is e power x minus e power minus x divided by e power x plus e power minus x.
So let me wrap up the session. So in this session, you guys discuss about what are the working of a neural network, and you guys play a role on its components. I think you are understand whole concept. Thank you for this session. Thank you everyone.
Thank you.